Started. My name is Jing Liu. I'm the executive director of the Michigan Institute for Data and AI in Society, MIDAS, which is the organization that is hosting today's lecture. Let's see. Yeah. Just a few words. We are a university-wide organization supporting the development of data science and AI methods and the application of these methods to a wide variety of research domains for scientific impact and also for societal impact. So for those who haven't been coming to any of our events yet, we do mostly 3 sets of work. We promote research, we enable research, and we lead research. We also offer a lot of training for researchers ranging from professors all the way to undergraduate students. We also build collaboration with other research universities, with industry, with government and community organizations, all around the theme of data science and AI. This series that you're attending today, we call it the Data and AI in Society lecture series. This is new. We started this several months ago, really. And this is actually meant for the community, for everyone. There's no requirement for any prior technical knowledge about these subject matters. The reason really is that artificial intelligence, as you all are aware, has really entered our lives in a very kind of significant way, starting really a couple years ago. And together with data science, they're shaping not only science, but they're shaping the society and human lives in very fundamental ways. So even if we're not necessarily all experts in these subject matters, we still need to know about them. We still need to know how we want to think about them. And we still need to, as a society, as citizens, decide how we let these technologies shape us and shape our society for the future. And this is really the purpose of the series. So before we come to today's topic, I actually want to announce our fall semester lineups. So the fall semester in the series, there are 3 lectures. As you can see here, we have Professor Jason Corso, who will talk about AI agents and equitable healthcare access in rural areas. We will have Professor Barbara McQuaid, who will talk about AI and disinformation and democracy. We also will have Professor, he's not a professor here. He actually is I think he was with Microsoft and also was a co-founder of Microsoft Research India. And so Mr. Anandan will be talking about AI in the global south. Okay. So we also have already announced the dates of our annual Data Science and AI Summit, which is November 17 and 18. I encourage you to consider saving the dates. This is the largest data science and AI event on the campus of the University of Michigan every year. Now I'd like to turn to today's speaker, Professor Jason Owen-Smith. He actually has many more titles than what you see here, which I won't read. But 2 titles I want to mention, which really reflect the work that he does in addition to being a professor. He is the Associate Vice President for Research, Institutional Capabilities, and Research Intelligence. And he's also the Executive Director and co-founder of the Institute for Research and Innovation and Science. So just as these titles indicate, Jason's work sits right at the intersection of innovation, research, and society. He examines the dynamics of high-tech industries and the public value of the research university, and seeks to understand the role of organizations, institutions, and networks in social transformation, scientific discovery, and technological breakthroughs. So he spent the last several years helping universities, policymakers, and the public understand how science and innovation shape real lives and what we need to do to support them in the age of AI data and rapid change. So if you've ever wondered how research investments translate into jobs, companies, discoveries, or regional prosperity, Jason's work is the kind that makes these connections visible and meaningful. His book, Research Universities and the Public Good, is a powerful argument for why higher education matters, not just for students and scientists, but for the future of our economy and democracy. Before I pass down to Jason, I want to mention that because this is a large lecture hall and we want to make sure that people all hear not only Jason, but also the questions from the audience. Let's try and save all the questions at the end. And at that point, our staff members will pass along the mics for the audience to use. With that, please welcome Professor Owen-Smith.
Thanks very much, Jing. That was a little embarrassing. Sadly, because Jing has given me such a lovely introduction, I have to begin with a disclaimer, which is that what I'm going to talk to you about tonight is not going to be a very satisfying story because it's the beginning of a story. What I'm going to try to do today is tell you a bit about how someone like me looks at where we are now and thinks about what the major questions we need to be able to answer are and how we need to be able to answer them in order to have a good faith shot at using data that we already have potential access to in flexible, effective, transparent, and responsible ways to allow us to do our very best to get out ahead of what seem to be big changes coming down the road that we're really, really unclear about the direction and impact of right now. So I don't have an answer, but I think I've got a direction. And part of what I would love to hear from you all is thoughts about how it sounds, things that are missing, because this is the beginning of a road, and it's one that, honestly, we're all going to be walking, I suspect, one way or another. I myself would like to know more about where I'm going, rather than less, in the ways that we can. And that's what this talk is about trying to do. So Jing's already given you an introduction. I won't spend a ton of time on who I am, except to say that most of my career has been focused on trying to use various types of large-scale data from administrative systems, from bibliometrics, from other sources, to create integrated systems that allow us at relatively fine-grained levels of detail and at scale to get at key questions about how innovation happens and has an impact in the world. Everything you see today, I'm going to sort of accept blame for. Nothing like this gets done alone. So, the stage set. Why is this AI thing a problem anyway? I mean, it's cute, right? You type some words in and it finishes your sentence. It's basically a parrot in your phone. Anybody have a device like this? I'm guessing most people do. So Devices like this are approximately 18 years old, younger than my oldest son. They were introduced in 2007, and they've sparked fairly big changes. So just pause for a second before we dive into AI. And for those of you who can, think back to 2007. Right, Barack Obama was president. And ask yourself, is there a job you can think of that is done differently now because of the mobile revolution that this device and the ecology it's part of helped to create? Is there a job now that didn't exist that you think was probably driven by the mobile ecology that this device helped to create? And does anyone think that AI is likely to have smaller effects than the smartphone and mobile computing? Right. Even if what you think is that the effects are about the same, I would argue that over the last 18 years, we've seen some pretty large effects from this device. And it's important to know that for all intents and purposes, Gen AI, as it's sort of known publicly, it's about 2.5 years old. So you can think of this question in terms of, given where we've been in the last 2.5 years, where do you think we might be in 15? That's the thing that we're trying to figure out. And it's important because people generally believe there are going to be some very big changes. So this is Jeff Hinton, who's generally thought to be, or called, the godfather of AI. He's backpropagation, one of the people who won a part of the Nobel in physics last year for this innovation. And he's said, you know, one, he's a bit unsettled by where things are going, but two, he said this is going to be as big as the Industrial Revolution, which was not a happy time, and lead to huge gains in productivity. And there's some less than fully serious predictions about what that's going to mean that mostly swing wildly back and forth between utopia and apocalypse. But the fact that they swing back and forth between utopia and apocalypse, ooh, I hit the wrong button. Right? Point to the fact that there's massive uncertainty. We don't actually know what's going to happen. We don't, in fact, maybe for the first time, know what the technology can do because we haven't fully designed a set of parameters into it. Right? There are a bunch of complementary technologies that are likely to really change the profile. Right? Changes in computing power, changes in robotic capability, changes in materials, a whole bunch of different things could shift the implications quickly. The data systems we're working with are insufficient to track things that move this quickly and are this diffuse in their effects. And that means that for a lot of people, it's kind of impossible to make informed decisions. We're all just kind of guessing. And so for me, it's interesting because AI becomes a sort of microcosm right now for places where science and technology and work and education and innovation kind of collide in fashions that have real implications for prosperity and opportunity, for the dynamics of business, for national security, right, for innovation. So there's a lot to be said here, and a lot of it has to do, for me, with the relationship between technology and work and the economy. So even here, there are big differences. We get away from the utopia, Terminator, Skynet went live on X date kind of problem. Some very good economists, when they run out their macroeconomic predictions about the effects of AI on economic growth, come to very different conclusions. In fact, these two very good predictions lead to a difference almost twice the size of Germany's economy over 10 years, which is sizable, right? And it doesn't come down to the models itself. It comes down to the fact that we have no consensus answer to some very simple stylized fact questions. And so both of these sets of economists made very different assumptions about the actual state of affairs today. And those assumptions changed the outcomes of the model in significant ways. We don't know things like how many employers are using AI right now? What are they using it for? Is it making current workers' jobs more efficient, or is it replacing them? Right? Are there new jobs being created? Are there workers that have the skills needed to do those new jobs, or do we have to change how people are educated? Where will those people come from? Right? All of these kinds of questions feed into the kinds of predictions that you make for the whole economy, but those kinds of predictions actually aren't crisp enough to let you make a decision if you're choosing a major right now, or trying to decide what kind of extra work you're going to pick up, right? Or where you're going to aim your next career search, or even who you're going to hire. To do that, you need a different type of data. And we want to do that because changes that automate large swaths of work make for big differences. The last time a major automating change hit the US, right, in the context of changing international trade relations with China, in fact, 7 million people, mostly in the Midwest and South, lost jobs in manufacturing. There's still debates about the effects of that, but there's credible work that suggests that it helped to drive spikes in inequality. It changed our political economy. Right? It's associated with, at least, some major shifts in public health, including some of the things that have been called deaths of despair. Right? In many ways, our current moment can be read out of our inability as a society to see and get ahead of a massive technology-driven change in work. And if we're facing another one, it would be good to be able to look ahead a little. So, be good for other things too. If we had data that was timely enough, near enough in recency, maybe a little forward-looking, that was local, pitched to the kinds of labor markets where people actually try to look for and find jobs, that was actionable, granular enough that people could use it to reduce the uncertainty of some of their key decisions. Right? It could help science funders, people who are trying to decide where to put money as budgets are being cut. It could help state workforce agencies prepare to get ahead of changes. How do we develop programs to help people whose jobs might be at risk, or to help businesses transition as skill needs evolve? It could help businesses identify the skills they're going to need, because this is one of the things that might be holding up transitions. Uncertainty about whether you'll be able to find the people who can actually do the work that you'll need once you've implemented new systems. Economic development groups, universities. What you'll see in a second is that these are all the different groups that you need data and expertise from to actually build the kind of thing that can answer the kind of questions that we need the answers from. And the reason this is important is because to build that kind of infrastructure, everybody who participates has to get something of value out of it. They all have to have a reason to want to mix their data chocolate with your data peanut butter. If there's not a tasty treat at the end, right, then this becomes a lot of work for little return other than Jason's curiosity. Here, there are a lot of tasty treats. And one of them is testing out some ways to think about technology and work. So there are two basic theories, approaches, that someone like me uses when they think about technology and work. new technologies hit. Labor economists, as just one example, is David Otter, follow something that they call the task-based approach. The idea here is that jobs are basically bundles of tasks that employers need done to be productive. You can see those in job postings. When you're looking for a job, here's the list of stuff you're going to do. Or if you write job postings, what you think about is what are the key tasks? Right? Workers hold skills that can be used to do them. You might actually write those into your qualifications. What's required, what's desired. Ooh, I hate that button. Now, the key insight here is that, generally speaking, employers can either hire people to do the tasks they need, or they can buy technology that will do the tasks they need. And they'll always pick the cheaper option, pretty much. I mean, there are details, obviously. And when technology replaces workers' skills, what it does is pull a task out of the worker's bundle, right? If enough tasks get pulled out of the job, the worker's value deteriorates. Often the job is lost, the worker is displaced. What's been called skill-biased technical change happens when job loss means that the people who lose their jobs have a ton of trouble getting back into jobs that pay at about the same rate. You go from being senior skilled tradesperson at GM to being a greeter at Walmart. An alternative view out of organizational theory and the sociology of work, this is Steve Barley, says, look, jobs aren't just separable bundles of tasks. They're really, coherent blobs, mixes of tasks and skills that people can draw identities from. Right? It's important that you were, a senior skilled trade at GM. That's part of your identity. And part of the skills that you brought to bear are part of how you enact that identity. It's part of your community. What technologies do is not change the price profile. They create an opportunity for action inside an organization that might change the way work is done, but it's not a foregone conclusion. It's not as simple as we're going to replace a task with the cheapness, because there are coalitions and internal politics and unions and licensure and, all of these things that mean that the technology creates an opportunity for interested players in and around the organization to engage in fights about what the technology is going to mean, how it's going to be implemented, who controls it, all of those kinds of things. And so what that means is that how the technology changes work kind of depends on how it gets introduced and what the mix of people doing the work are and how they're connected to each other. And so the employer's desires are often thwarted. And this is really important because what it means is that if we can figure out something about the differences between these two, and I think they both got things right about them, and how to measure together with them, what we can begin to do is nail down the conditions under which we expect to see some kinds of implementation with some kinds of outcomes and others. So, how's this all boiled down? In empirical terms, I'm going to try to answer 3 questions today, or at least start 2, and then tell you what we'd need to really answer these at scale in real ways. Question 1 is, whose jobs are exposed to AI? By which I mean, who works in a place where either their employer, probably their employer, or coworkers, could be, are systematically employing AI at work. I work at such a place, the University of Michigan. Our CIO has a whole suite of AI products that are available to use. They don't tell me I have to, but I use them, experiment with them in a variety of ways. Right? Whose jobs are susceptible to positive or negative effects from AI. So you might work in a place that is using AI, but you might do a job that AI can't affect at all. Right? The prototypical example of that is often a construction job, especially a skilled construction job, masonry, bricklaying. Right? Generative AI is not going to lay a brick wall or nicely point a chimney anytime soon. Maybe once the robotics are there. So you could be in a company that is using AI all over, doing a job that AI can't touch. You're not susceptible, but you're exposed. And then the third question, can we say anything about what skill needs are emerging? What new jobs are coming up? Think back to that cell phone example and the idea of an app designer in 2005. Right? Wasn't a job category that was meaningful. We don't know what job categories will be meaningful in 10 years. We thought for a while prompt engineer would be, but it looks like you can just ask ChatGPT to write its own prompts, and things will work out kind of okay. So, if you wanted to put this in really concrete terms, what we're trying to figure out is something like this. Foundation models routinely pass the bar exam, quote unquote. Today, or at least last year, according to Bureau of Labor Statistics, there are about 1.3 million lawyers and about 366,000 paralegals working in the US. What do we think is going to happen to their jobs? And do we think it's the same thing? It's worth pondering. And I will come back to it. I would argue that it depends. And a huge part of what it depends on is the combination of exposure and susceptibility, which we don't currently know how to measure. If you want it another way, because I like to make this personal, I asked our ChatGPT, after feeding it some of my writing and the description of this talk, to make the first slide of the talk. I told it to give it to me in a LaTeX markdown form so that I could just print the slide. And this is what it gave me: a foggy landscape image and some bullet points. It's actually not bad, honestly, given that it was a one-shot prompt that I just sort of banged out really quick. I could have gotten it better. But this is basically my equivalent slide. And so when you look at these things side by side, if you wanted to really concretize this, part of my job as a professor, right, part of it's giving talks like this, but part of it, honestly, is to build things like this that help make sense of phenomena like this for students in the classroom. Right? If my university can get something credible in 10 minutes from an AI, does it need me? And this is the way the question plays out, right? If my job's exposed to AI, and it is, and it looks like AI could be taught to do credibly some of my tasks, probably can, does using it make me more valuable to my employer? Does freeing me up from all of the time and effort of creating slides mean I can do stuff that the University of Michigan would value more? Or does it make me less valuable because they can automate the stuff that they pay me for? Right? Does it challenge or support my identity at work? Or does it make my job less fulfilling to me to know that AI could maybe have given this talk? Right? These are the kinds of questions that at the end of the day we need to figure out to be able to get to these issues. And just because this came across my desk as I was making these slides, last night the CEO of Anthropic went on record saying, you all should be afraid. You should be very, very afraid. 50% of all jobs are going to be wiped out in the next year or two, right? And it's mostly going to be young, white-collar professional jobs. Right? So lest the place where we're seeing this right now is in entry-level coding jobs. This is just a graph of postings for new entry-level software developers on Indeed. Right? ChatGPT is introduced about here. Right. So, something's happening. Could be that 50% of all jobs are going to go away, and it's going to fall disproportionately on people in the 24 to 35 age range with college degrees and master's degrees. And, you know, it is, as Dario Amadei says, going to be a bloodbath. And we're not prepared for it. What do we need to get prepared for it? How do we prepare the people? How do we prepare the employees? How do we think about policy? It could be that nothing's going to happen at all. But the fact that we don't know is not promising. To know, we'd want to be able to identify exposure. What employers are plausibly using AI now? We want to be able to identify the actual kinds of tasks that people do at their jobs. We'd want measures linking what AI can do to what people do, so we know what possibly could be replaced. We'd want employer and regional level data, not just big national data, because at the end of the day, when you're making decisions about your local environment. It's like a weather forecast. Right? If you're trying to decide whether to take an umbrella to your picnic, it doesn't help you to know the average temperature across 10 states in the Midwest. You want to know what's going on in your backyard, even if it's a bit more uncertain. You want means to identify the emergence of new types of work, because when you're making decisions, you're often making decisions for the long term. You're wanting to play ahead of the game. And you want links, where possible, to education, training, and sources of workplace skills, because you have to validate this information, and because, ideally, you want to be able to create programs that can align the way people learn stuff with the things that need to be learned. This is a tall order. We don't actually have a data system that can do this. But I think we can build one. And we've done some pilot work. So where's technology being used? First, some findings. Somewhere between 5 and 82% of employers %40 of work activities, 80% of jobs, and 2/3 of occupations are at risk of being affected somehow by AI. This is not heartening. We've recently run a pilot project, and it is just a pilot, to test a new approach to trying to measure this at scale. It uses administrative data, and I'm going to walk you through it. We're looking at research investments in what are called critical and emerging technologies, focused on trying to get to a measure at the regional level of jobs, earnings, and employers that we can link back to investments in fundamental research related to a technology. Right? We're doing this for AI and electric vehicles in the state of Ohio, and the goal was to build a prototype of a data system for one state that we could scale to many, and to demonstrate that we could produce measures initially that states, universities, federal agencies would find valuable and help us sort of move in the direction of things that they could actually use for the kinds of purposes we describe. Why? In 2022, the CHIPS and Science Act was passed, and one of the things it did was fund the Technology and Innovation and Partnerships Directorate at the National Science Foundation. This is the language in the act that funded the directorate, and one of the things that it says the directorate is supposed to do with its research investments is grow the domestic workforce in key technology focus areas and expand participation of United States students, et cetera, et cetera. And at 5 years, it's supposed to review whether federal investment in key technology focus areas have resulted in new domestic manufacturing capacity and job creation. Needless to say, NSF does not know how to do this. But it's becoming more and more important that NSF be able to do this. The current budget puts a 56% cut on NSF. Right? That's the budget proposal on the table. One of the things that they're being pressed on is being able to demonstrate these kinds of impacts. So they funded a pilot project, which raises a challenge. This was the press release for the pilot project, for what it's worth. And the problem here is that in data terms, AI is not really a thing. There's not actually a code in any science or technology database that you can type in and say, give me all of the AI papers. Right? You can't do it with grants, can't do it with papers, can't do it with patents. You certainly can't do it with industry. There is actually an industry code for AI, but it used to be the code for nanotechnology. They just sort of moved it over, and it now holds things like Anthropic. But that sells the uses of AI very short. And so both the inputs and the outputs are impossible to manage, and the current data infrastructure won't let us get to the regional level of analysis and is way too slow to handle these technologies. These, by the way, are the critical and emerging technologies. There's AI. Right? But all of them have this character. They're, generally speaking, things that aren't easy to measure, which we need to figure out how to measure. And it's important to note that in NSF's proposed reorganization, all it's supposed to be focusing on going forward is 4 of these areas. So it's going to be very, very important to understand the implications. So how do we do this? We make an assumption. Assumption 1, people are the core thing that we want to index to. Research at the frontier tells us not where technology is, but where it plausibly could be going. People who are doing research learn the skills needed to take new technologies and new innovations out into the world and start to apply them. And people who hire those people are, at least in principle, buying in to have access to the skills needed to apply new technologies. What's this look like in practice? We start with 100 million scale publication metadata. Data on all patents publications from the Elsevier scientific corpus. And I'll tell you about how we do it in a second. But we identify people who are writing papers that use or develop AI. We link those to data that IRIS maintains that comes from university HR-sponsored projects and procurement data. This tracks the direct cost expenditures of every sponsored project grant a university has. So for every grant on a campus, we can see every person paid by that grant, every purchase of goods and services from a vendor, every subaward. When we make this linkage, that lets us see what grants are paying these people who are doing AI research and who else, students, technicians, staff, other faculty, are paid on these grants. Because those people are employed by the university, we can link them to the state of Ohio's unemployment insurance wage records. All 50 states under the Unemployment Insurance Act have to receive from every unemployment insurance eligible employer in their state every quarter a record of how much money the employer paid to the person, because that's how you know if you lose your job what you're eligible to receive. Those data are, under certain conditions, accessible for uses like this by state workforce agencies and others. And this link allows us to see when someone who was trained on a research grant that we know is connected to an AI author leaves the university and gets a job in Ohio, who hired them? What are they being paid? That allows us then potentially to flag employers who might be moving into AI and to develop about them data about their entire workforce, the trajectory of its hiring, its earnings, churn, turnover, locations, things of that nature. So this is the pipeline to start to try to get at a new way to do exposure. Don't bother with that, except to say this is the details of how we did the authorship. The short version is we asked a bunch of experts how they would go about finding people they were pretty certain were AI scientists, and their answer was these 21 machine learning conferences. Right? If you're getting papers accepted in these conferences, you're doing AI in our book. So we developed this big graph, and we identified those authors, and we labeled them. And then we propagated through that graph And we identified co-authors and people who'd cited them and people, right, who were publishing in the same journals. A bunch of different layers. And then we built a model that predicts, for people who aren't labeled but are connected in various ways to people who are, what's the likelihood they're doing AI? We validated it against a bunch of different samples. Model's still being improved. We've been through 2 rounds. We're working on 3rd. But what this does is get us to a set of individuals found as people who we can then read characteristics of the technology out of. And when you do that, this is a map of the topics that US federal grants that have those AI authors as PIs in the last 5 years address. These come from all federal funding agencies. So only some of them are what we call core AI. AI tools and compute, right? There's optimization, there's deep learning algorithms, there's language processing, right? Most of them are applications of various sorts because AI is what you might call an enabling technology. It's something that you do discovery with, but it's also applied in all kinds of places. Right? For instance, what we call engineering and applications technologies includes AR, VR, you see it in marine robotics, polymer materials, and another robotics cluster that's mostly about disaster preparedness. So the idea here is that now that we have this, we can see the people who are working on these grants, and we can begin to track both where the technologies are and ideally where the people go. You can also boil this down to the national profile, the profile of the state of Ohio, and the profile of Ohio State University, which is our model for linkage to the unemployment insurance data. Which is what brings us to IRIS. So I won't spend a ton of time on this, but IRIS collects data from universities around the country and does a ton of work with it. Cleans, integrates, links to about 60 different data sources. What's key is that we see every person, subcontract, and vendor. And the every person here is very important because not everybody who's important to research or who learns important skills while doing research ends up an author on a paper. In fact, most of them don't. Right? When we link those AI authors through, for 28 universities, the 35,000 AI authors that we find, and when we walk through all of the grants that pay them from any source, we find all the people that worked with them on those grants, but weren't themselves authors on the AI papers we identified, we find another 381,000 people, of whom 63% are students. This is an 11-to-1 ratio. Right? These people are people who are doing work on grants in a wide range of fields, funded by lots of different federal agencies, companies, foundations, that is either developing new AI tools or applying them in ways that are sufficiently novel that they're being funded by federal science agencies. When we take this money, these names, with flags for AI, non-AI participation, and some threshold measures, to Ohio, we can then link to the UI wage record. We're still waiting for this, so this is just mocked up data. We haven't gotten this disclosed yet. But what it'll allow us to do is the Sankey diagram. You worked on grants in these areas, and you've got jobs in these industries. What we know right now is that there were about 2,300 people who worked on grants that we identify in this time period. About 52% of them we see get employed in Ohio. Right? There's a pilot, one state. So, like I said, not satisfying, demonstration. We also need to think about thresholds. So there are 2 ways that we think about how you could put tighter or looser on this. Right now, what we can say is, you get hired for any job. And the key thing about the wage record is that, at least in Ohio and in most states, it includes no information about the job at all. It tells you person was employed in this quarter, paid this much, who the employer was. If you looked at the wage record for the University of Michigan, you'd think the football coach was the president because they're paid so much more. Right? There's no occupation or job title information. And so we construct two thresholds. One's based on the publications that we find for all of these people and the character of the grants. How intense is their work in AI? Right? One is based on the character of the job. Are they hired do we see them hired for a full year at a salary greater than $80,000 a year? Right? When you apply those, these are just some examples, but if you just say any job at all, even if you worked for a month at Panera before you got a full-time job, right? We're going to count that as AI, right? That's it. If we just say high intensity, right, we see an interesting pattern. If we just say full-time employment, we see a slightly different pattern. And if we put both on, what we get is the very core researchers who are doing algorithm development. And so we're doing validation with this now, and we'll continue to expand it, particularly through partnerships with employers. But what I'm going to be showing you today is mostly based on this. This is what we're hearing and starting to see is probably the most effective. The supermarkets, full-service restaurants, and limited-service restaurants seem to be a function of problems between headquarters and branch. So headquarters locations seem to be hiring a good number of AI places, of AI-type folks, but your average cashier is basically waiting for the AI to hit them. So now that we've got all these links, what do? So if we've got research investments in universities, and we want to know, for instance, how many jobs in manufacturing are touched by AI, I call this a tale of two chips. There are two 6-digit industries that make chips. Tasty, tasty corn chips. And not so tasty silicon chips. If we observe AI scientists being hired from research universities into one industry but not into the other, these things roll up into higher level industries. And basically, we apply the thresholds at the level of the 6-digit NAICS code. And so the more hiring we see into employers in the 6-digit industries, the more confident we are of the roll-up. And that lets us say, okay, here's a snapshot for 5 sectors. These are sectors that folks who do economic development are particularly interested in because they tend to bring money to the state rather than circulate money around the state. This is a snapshot in green, dotted line of the sector, and within it of what are called 3-digit industries, so slightly more fine-grained. Size of the bubble is the number of jobs. This also reports the number of employers in the state. So this gives you a snapshot of where the most jobs are exposed to AI, but it tells us nothing at all about susceptibility, right? So all we know here is that plausibly these employers have hired people who know how to do the work to apply new AI technologies. And if we run it through, we can get down to the regional level, which is where things get very interesting. Because, for instance, around Cincinnati, which is where the highest concentration of folks who are in these industries on our threshold are located, right? This is driven almost entirely by healthcare. Remember all of those big NIH grants and the disease category. Right? And what it's doing in healthcare seems to be bifurcating. Right? The more for-profit side of healthcare, not the social services, not addiction services, not elder care, right? But ambulatory hospitals, surgery centers, things of that nature, are moving very fast. And the places in healthcare that are touched by AI or exposed to AI seem to be paying a lot more than comparable places. This isn't a causal claim yet, but we're developing what we need to do it. The same thing is not true of manufacturing, which doesn't have as much penetration yet, but isn't seeing the bifurcation of earnings. The picture looks different when you move to Cleveland. And so when you start talking to policymakers or people who are developing programs, right, we don't have the last part of the picture that we need, which is the susceptibility. But you can start to see how you might have to tailor different kinds of interventions to places that have different kinds of industrial bases, even within the same state. Right? Because Cincinnati's healthcare looks different than Toledo's healthcare or Cleveland's healthcare. In the same way that the UP is a different region than Southeast Michigan or the Thumb. So, exposure, susceptibility. So imagine we've got a world in which there are 4 possibilities. I said earlier that coders were kind of, highly susceptible and exposed. These are the jobs that we're going to worry about right away. Right? There's another class of jobs that might be exposed but not really susceptible. This is a picture of a data center HVAC engineering designer. Right now, people who build data centers, there are not enough of them, so if you have the right skills to build the cooling system for a major data center or to do that kind of electrician's work, right, you're much in demand. AI is not going to replace you anytime soon. But arguably, coders might be susceptible but not exposed. Right? If you're the only dev working at a mid-sized accounting firm in, make it up, Bar Harbor, Maine, right? You might be using AI and no one might know. Might make you just 2-3 times more effective at your job. Right? Your employer might love you. Right? They might pay you more. Or maybe you can get all of your work done in a day and they just don't know. Right? The exposure and the susceptibility go together. And then there are people who are probably not exposed and probably not susceptible. And the interesting category, which I think is much more common than we think about, is a picture of a neurosurgeon. Right? Some of the things a neurosurgeon does, like write up case notes, AI could probably do very effectively. And other things a neurosurgeon does, like 10-hour-long microsurgeries on a living brain, we probably don't want ChatGPT trying anytime soon. Right? And so what do we do with that person? Or, for that matter, back to the lawyer and paralegal, with the lawyers and paralegals, right? Who both do document review, but one also might argue in court. Right? One of those tasks is something that Gen AI can do right now. One, maybe not. Right? So there are 3 ways that people have measured this so far. The 2 most common are at the top, and a new emerging one is at the bottom. The most common 2 are either you take a measure, usually from a benchmark set of models, and you go and you crowdsource a survey where you say, here's a bunch of things that this AI model can do, and here's a bunch of descriptions of what this job needs. Tell me how well you think this job could be done by this AI. And then you use it to create an index. The other thing that happens a lot is you look for descriptions of jobs and descriptions of technology capabilities, and you align them using various types of word embedding or LLM embedding techniques. And then there's a new data set I haven't spent a ton of time with yet, but Anthropic just released, that is analysis of actual de-identified prompt and response chains from Claude, which are an effort to understand what people are actually using the technology for. But they have no idea if it's actually people using it at work. It's just what people use it for. So it could be me, working on my passion project role-playing game, not actually coding for my job. But it is using for coding. Right? And so this is where we start to get to the big questions for this. Right? And I'm going to warn you that the answer is still going to be we don't know, but we're going to know a lot more about what we need to know. So, what do we think we know? There's mixed evidence, but it looks like early career white-collar jobs seem to be the most at risk. more physical tasks and more unpredictable tasks, more ambiguous tasks, are more inoculated, right? AI is not going to be driving a forklift over broken terrain with an unbalanced load anytime soon. Right? There's real uncertainty as to the complementary skills that might be needed to make AI something that's good to adopt. And so part of what we see is that really large-scale enterprise-level adoption, like Walmart building a bespoke AI that's going to revolutionize the way that all of its employers deal with customers. That kind of adoption, rather than buy an enterprise subscription to ChatGPT, throw it at your workers and say, see what you can make of this, right? That's getting slowed down because senior leadership is unsure of what they will need in terms of things like regulation and new HR and training and all of the skills that have to wrap around a giant technology in order to understand it, right? And that means that they're a little hesitant. One of the reasons why business people are interested in the skills question. Progress is jagged. This is Ethan Mollick's term, but the idea is that this technology has shown over and over again that there are things that you wouldn't expect it to be terrific at that it turns out to be pretty good at, and there are things, at least early on, that you would expect it to be good at, like math, that it turned out not to be. And so what most people are doing right now is figuring out how to carve out time to experiment with AI on the job. And it's very much a kind of inductive experiment, carve out 10% of your time and figure out what you can do kind of thing. But that means that there's not a lot of forward motion, and there's a lot of room for people to figure stuff out that they don't keep from that they don't give to their employer. It's not actually entirely clear who will benefit most from the way that AI is being employed at this point. Whether employers will see a benefit at all is an open question. It appears from a few field studies, and there have only been a couple of these, and there have been some survey research that contradicts this, but I like the field studies, so I put it up here. It appears that in many places, current AI helps people who are new or nearer to the bottom in skill in their place. This is in call centers and consulting groups. This is where this was done. It doesn't help the best performers. It doesn't bump them seriously. What it does is close the gap between the best performers and the middle and the bottom of the distribution. So far, few jobs have been totally replaced. We may be more, and I'll show you some data that suggests this in a second, in a vein where we're starting to ask ourselves, how do we understand jobs where one or two tasks may get changed or replaced by this? What does that do? We don't actually have a model for thinking about that very well. And the total automation is pretty rare. There's big fights going on about the implications. One group thinks that we really need to change up the way we design AI and stop trying to replace humans, to say, we can do everything a human can, and start to build a more human-centered design to facilitate this kind of fluid experimentation. There's another group that thinks we're doing just fine, and what's going to happen here is that this is going to break the monopoly of expertise of groups like lawyers and physicians and professors, and it's going to open up a much wider sort of middle tier of jobs. I don't know. I think we can get signals. So if we return to theory, we've got to ask ourselves, what's the right level of analysis? Is it the occupation? Lawyer? Is that the job? I'm a contracts lawyer at Disney in Orlando. Notice that the job is not the occupation. There are lots of different ways to be a lawyer or a professor. Right? Is it a task? One of the things lawyers do is review and redline contracts. Right? Or is it a particular skill or capability, knowledge of contract law, that allows you to do a particular task? And back to the distinction, these are really just bundles of separable tasks or clusters of coherent activity. Most analyses anchor on a thing called ONET. ONET's a standardized data set that the federal government produces for about 1783, I think, occupations. It standardizes about 28,000 task descriptions, and it associates a bunch of stuff with those tasks. The most important for our purposes are what they call abilities, attributes of the individual, things that people can do. Activities, right? Basically the skills that go into doing a task, and the occupation. There's a bunch of other stuff that goes around it, but what's important to note is that when people have surveyed about what capabilities AI can replace, they tend to survey about these abilities and to roll them up to occupations. And when people have tended to match patent data, technology descriptions, to things, they have tended to match them to task descriptions and rolled them up to occupations. To put this concretely, here's a description for lawyers. I use lawyers because, I know a bunch, and I care and love them desperately, and so they all hate this. Because these are generic descriptions. They're meant to be descriptions that hold across all attorneys, which is a problem, and we'll talk about it in a second. But the idea is that there's a description of the occupation. For each occupation, there's a set of tasks, usually around 20, that make up the task. The tasks are flagged with importance, frequency, variety of other measures that come from surveys of lawyers. There are activities that comprise the tasks, and then there are the abilities that go into it. And so the AI Occupational Exposure Index, and here he uses exposure to mean what I mean by susceptibility, but never mind, is a Z-score standardized measure that basically takes those abilities, uses the weights on the occupation from ONET to roll them up into an occupation level measure based on mechanical Turk weighting of what a foundation model could do in 2022. So this is behind the times. It's slow, but it serves as a pilot, right? If you just take their measure, these are the top 10 occupations at risk for AI. It's kind of a weird list. Right? It's hard to imagine judges getting fired. But budget analysts, business BI, maybe. Genetic counselors, I don't know. So it's kind of strange, but we can see. You can actually recalculate this, though, because if you remember this, what they did was take advantage of the link between abilities, which they've flagged with how well can an AI do this, and they rolled it up to occupations. But occupations might not be the right level of analysis. It could be the tasks. And so we can take that and we can also run it through activities, which have the same connection, into tasks, and roll up from the activities to the tasks using the same method, and ask, what tasks does this measure suggest are susceptible? And when you do this, this is the top 5% most susceptible tasks. And they're arrayed on a standardized XY, where the X is the percent of people in the occupation who say they do the task at least daily, and the Y is a 0 to 100 index, 100 max, of how important the task is to the occupation, according to those survey respondents. Purple is a code ONET puts in for what they call core tasks. These are tasks that are essential to the occupation. Blue, supplemental. And what you see here is that the most AI susceptible tasks are actually spread from almost completely unimportant and never done to core, done daily, and maximally important. And they're distributed, kind of willy-nilly. I mean, there's a little upward trend with time, but there's nothing here that suggests huge clustering. And in fact, it starts to get to the question of, what would happen? Because if you could take a bunch of fairly common but only moderately important and not core tasks off my plate with AI, I'm betting that would make me much more effective at some of the daily, very important core tasks. Right? So what happens if we redo this group of investors, not at the occupation level, but by asking what percent of your tasks are highly susceptible in the top 5%? And you get a different list. In fact, Only business intelligence analysts are on both lists. So if you're a BI person, this list feels a little better, but we haven't validated. Right? We're working now on the partnerships that will start to let us, and there are a variety of ways we're going to. But what it looks like is that tasks may offer more discernment, and so that raises the question: do we need to go through the capabilities at all? Right? Does it make sense to say, knowledge of the written word is an important capability for the task of evaluating contracts? Let's work through that and say AI is really good at knowledge of the written word, therefore it'd be really good at contracts. When instead we could just do what otherwise has been done, which is to use, in this case, SentenceBERT, and work through to match up the text of patent descriptions with the text of task descriptions. Right? And so these are the titles. This is just a random sample from a much larger set, but these are the titles of some patents and task descriptions that were very close to them, to the text of the patents in a SentenceBERT-derived vector space. And what they do is they give you a sense that, we don't know if these patents are being done, but a patent on techniques for compliance testing, and these patents are all drawn from a corpus of AI patents identified by the US Patent and Trademark Office in collaboration with the European Patent Office. Right? So these are AI techniques for compliance testing, and if your work task is to identify compliance issues that require follow-up or investigation, it might be that an AI automated compliance testing patented technology could come for your job or part of your job at some point. And so we could ask, what happens if we define the top operations by percent of highly susceptible tasks defined by patenting as opposed to by this thing? And the answer is, well, damn it. It's a totally different list. Right? Now, this list is interesting in that it has much more in the way of people who are actually controlling systems that have some physical component. And so if this list is more accurate than that list, right, it suggests that what the technologies do with the tasks is interpose automation in systems that did have some physical component to them before. And that suggests a different kind of job model that might be affected than the it's all coders and paralegals picture. But these are the correlations, and they're abysmal. So we need to do more to figure this out, and there are 6 problems, I think, that we're going to need to solve. This is my best, these are the abysmal correlations face. So problem 1. Most jobs have some tasks that are at risk. Something like 73% of jobs, remarkably stable across both of these measures, have at least one task that on one of these measures is highly susceptible to AI. Right. Again, validation needs to be done, but we need better ways to think about not our job's going to go away, but how do we manage, how do we think about what happens when parts of them go away? Problem 2. The tasks don't all hang together equally. I'm sorry about the fonts here. They were sized differently when I looked at them on my screen. So instead of thinking about tasks as bundles, we might think of them as networks. I'll show you what that looks like in a second. It helps, I think. And some tasks are so AI unfriendly that they protect people's jobs. So I showed you the most AI susceptible, but there are also tasks at the bottom of the distribution, tasks that are really, really, really AI unfriendly. The prototypical example here is, works in a slaughterhouse, being a butcher, right? These are not the sorts of things that Gen AI will do. So if we wanted to think of this as a network, we can also take advantage of the fact that tasks, supplemental and core tasks, here nodes are sized by how important and frequent they are, and activities, which in this case have the standardized Felton and Siemens measure associated with them connect to each other. And you can run these through and turn them into a network and ask, how well connected are the tasks in this job and skills? One answer might be that the more coherent, the more dense, the more interconnected a network is, the less likely you are to have the loss of one skill, or even a couple of skills, to AI, degrade your job, right? Because it won't change a ton of other things. It may just free up your time. Right? And there's some evidence for this. So this is a measure of task interdependence, right, across levels of susceptibility. Right? And it looks like your susceptibility goes down. Right? And here's a snapshot. So this is where I think we need to go. But I think we need to do it with something other than occupations. And I'll show you why in a second. Regardless, here are 4 images. Purple nodes are highly susceptible to AI. They're in the top 5%. These are the things that you would expect to be most automated or automatable. Yellow nodes are highly inoculated. They're at the bottom 5%. These are mostly physical tasks, things that require you to interact physically with the world or with a person. Right? And I chose these 4 as examples, but if you look at them and you had to guess which of these 4 is in the most danger from AI, what would your guess be? I've already tipped the hand on business intelligence analysts. I'm maybe flogging a dead horse here. But what's important, right? There's interconnectivity. There's also the number of important things. Here, there's a really big, central, important AI thing. But if that went away, there's also, these 3. Occupational therapy requires that you have a lot of physical contact with a patient. You often have to physically position someone. It requires a lot of tacit knowledge, right, that AI can't do. This actually turns out to be a task that's about record keeping, medical record keeping. So this may be the neurologist or neurosurgeon case that I told you about, where if you could remove a task that actually got in the way, this may augment, may make this person more valuable to their employer. Right? As might this. Right? Here, both the high inoculation task and the high at-risk task are essentially completely separated from the middle of the network. Right? And the lawyer, there's a bunch of stuff that the occupation does that's not terribly at risk, and what would be lost by losing these 2 is actually a set of stuff that mostly has to do with contracts. The stuff that's more inoculated mostly has to do with trial work. The challenge, there's also some interesting evidence emerging that these jobs tend to be more female than male. So one model of this, if it holds, is that it looks like young women in white-collar jobs may be in trouble. Very different than the last version. But, again, we don't know early. In order to know, one of the things we'd have to do is move from occupations to jobs. So these are 2 job postings, just chosen at random from a data set of job postings for lawyers, posted in the same month. The important point of this, I've highlighted 2 tasks in the job posting. And if you look at these, they're actually fairly different jobs. They're both lawyers, They're both doing lawyer-like things, but they're being asked to do somewhat different tasks. They're being asked to mobilize different kinds of skills. They're doing it in different industries and in different environments. Right? It's not unreasonable to suspect that these tasks might actually be differently susceptible to AI, even though they're both lawyers. Right? So when I say we need employer-level information, what we need is to be able to take things like this, pull the tasks out of it, and attach those to things like the patent data so that we can see change. We also need to be able to see where they are, because this is a map from 2000 of where manufacturing jobs were before 7 million of them disappeared between 2000 and 2018. And they mostly disappeared from the green and black counties. Right? We are not currently able to draw a map of where jobs that might be affected by AI are. We might want to be able to. So, we also don't know how needs are changing. I'll do this very quickly. This is an example from some work we're doing with the Electric Vehicle Center. But it is possible to take those job postings, these are 1,100 as a pilot from Michigan for electrical engineers in the automotive supply chain, where we built a little model that pulls out sentences that are associated with tasks. And then we clustered those tasks in a semantic embedding space. The colors here are clusters. And we worked with experts to identify the clusters of tasks that were associated with electrification. So these are changes in the tasks of people who are hired into auto jobs and engineering roles as firms electrify their production. Right? And as an example, here's one. We used a human in the loop to round prompting process to get to these little descriptions based on the tasks that were in the cluster. So this was battery electric vehicle engineering, and it gives you a sense. What's interesting is if you come back to these clusters that are not electric vehicle things according to the experts we worked with, but are really proximate to them. It turns out that when you look at them, the things around them are very tightly related to electric vehicles. This is an AI simulation, digital twin set of capabilities. I give it as an example because being able to run this kind of thing over time, or to compare, in the case of electric vehicles, for instance, what career job postings for, say, engineers look like at Rivian, which was born electric, as opposed to what they look like at a GM plant that is busily shifting its powertrain production from internal combustion to electric, right, gives you a sense of where things are going. And that, combined with some of the technologies that do exposure, particularly if we can add this into the network of tasks and skills and ask which of these tasks are susceptible, and start to use measures like, how central, how connected, how many inoculating tasks are they, how integrated are these tasks, can get us to a position where we could, in principle, really start to tease out the difference between the neurosurgeon and the bricklayer, or between the lawyer and the paralegal. And maybe the difference between when GPT getting good enough to make my slides the way I would make them, right, will make me obsolete, as opposed to where it will make me 3 times as productive because I can focus on things that only I can do and leave the slide making to the AI. And in order to do that, what we need is this: employer-level data, information that can let us get at what's new, what substitutes, what augments, all of these different things that at the end of the day are going to come down to a way for us to work with partners who own these data to make sure that we're actually getting signal that we can validate against their records, right, and that we can use to produce information that actually reduces uncertainty for them and for their stakeholders for key decisions. because that's what's going to make an infrastructure work. And we desperately need a new infrastructure, even if you only believe half of what a prediction like Dario Amodai's says. Right? Chances are good that they're going to be fairly large changes at work. Right now, we know nothing about them. There are ways we could know about them. The data exist, but they lay around in a variety of places, and we need a way to build them. Everybody agrees we need a sparkly fountain. Lovely data fountain. Something that will tell us in as near to real time as possible, where are the AI jobs, who's susceptible, what skills are emerging. The problem is, to have a fountain that works, you actually need plumbing. A lot of that plumbing in the data space is standards, transparency, the ability to see how measures are built and to replicate them with your data. And in order to do that, you need a community of people to work with you. This image is from a guy named Terry McConnell. I stole it because I like the sparkly fountain so much. And so this is what we're trying to do. What I showed you starts here with bibliometrics to university administrative data to state unemployment insurance records. What we're now working on is the addition of job posting data linking into state unemployment insurance records, and through what are called state longitudinal data systems. These are state-managed data systems that link higher education data to the wage record so that we can see when people get their degrees from universities in a state, for instance, or community colleges, what degrees they have when they take a job. Being able to bring in skills data derived from job postings and task data of the sort I was showing you, as well as credential data, allows us all kinds of interesting possibilities to ask the kinds of questions that we can't currently ask. Because what it can give us is employer-level susceptibility measures and potentially networks of tasks and skills that we can drive down to the regional level and connect back to particular technology areas. And measures of exposure, ideally for multiple states, driven by multiple universities. And if we do that in partnership enough, right, with more stakeholder groups, I'll show you a list in a second, right, that opens the possibility of interesting validation. Because, for instance, there are several community colleges in states we work with that have contracts from the state to do workforce development work. They're partnered with employers who want to hire people from them. It'd be a relatively trivial matter if we have the records and the data to sit down with those folks and try to figure out, right? Do your job postings actually describe what you're having these people do? How do your HR job descriptions match up with the job postings? Are we actually capturing the jobs that you think are being affected? Are these credentials lining up with what you think the skills are? Right? These are the kinds of work that we can do. And to do it, these are the partner universities of IRIS that provide data. Or various advisory boards, partners in developing some of the standards to have this kind of picture. And the reason I show this is because in order to do it, the idea is basically, what we want to do is create, using some new technologies for data sharing that are basically secure cloud environments. Places where data intermediaries, like IRIS, can bring information from communities into a shared environment where data can be linked without it having to be transferred. You can maintain control of it. And this can allow a sort of federated, bottom-up data sharing system that's very flexible and that has some really nice features for the kind of thing that we are talking about doing. First, it potentially allows local coalitions. A university, a couple of businesses, a state agency, working together around data to answer a question for their region. Right? If we do that in the right way, the code, the measures, those can roll up and be moved to other regions and adapted. It allows states essentially, and regions to become laboratories for figuring out how to do this and how to use data to build the kinds of programs that will get us where we want to be, and a way to develop them out. So the question is, how do you model that? There are 4 models I can think of, and we haven't settled on one yet. Part of what we're trying to do is figure out what works with our various partners. One model is something like Linux. You have a tightly controlled data kernel, a set of things that everybody can use and can use for pretty much any purpose, and that the use of which doesn't require everybody else to deal with it. That could be something like AI identification or critical and emerging technology identification, but it might be too narrow. Another image is something like the National Weather Service. Right? So here you might imagine a world in which you partner with states and data providers who are each doing local stuff, and time is up. And aggregating it nationally. There's another image where you add to a big machine, and a third where you wire up a bunch of stuff that people are already doing and standardizing it. The goal in all of these is to actually get a plane that flies so that we can see where we're headed. Thanks.
Raise your hand if you have questions, and we will send you a mic.
Hi, Professor. My name's Martha, and I work with undergraduates here.
Hi, Martha.
So one of my questions is, with all this data that is available, it seems like there wasn't some that came from non-governmental organizations or businesses, and maybe that would shed light. But how do we get people to like play fair and share when there's real risk that some kind of monopolist, and some people might look at the University of Michigan, in fact, and say, hey, they've got enough resources that they could make already their own U of M GPT, but the community college down the road doesn't have those kind of resources. So how do we get people to share, and how do we avoid not only that kind of monopoly of information control, but monopoly of who has enough to invest? A state government might not want to do it. We see federal agencies not wanting to do it anymore. And so even the data sets that we have might not get kept up.
Yep. It's a great question. So one of the things I didn't touch on, because I was worried about going too long, and I did, for which I apologize, is all of the questions that go into the building of AI as a product. You're hitting some of the most important. Right? So one of the reasons that I am interested in this is because I think this is an important enough technology that it is very important that more than just a couple of institutions, of corporations essentially, be home to people with the knowledge necessary to understand the technology in the future. In order to do that, places like this one, small businesses, governments, right, need the capability to have people who have access to the data, to the models. So that's getting harder and harder to do. And increasingly you're seeing a bifurcation between people who can kind of do open research on small models and people who have to do more closed research on really big models. Figuring out how to change that is going to be a really important thing. It is not what this project is about, but part of the design of the infrastructure I'm describing is very mindfully built around an idea that there should be no single points of failure or control. When I use something like an open source model, right? These data are privacy protected, they have legal protections on them. It's very important that they be handled responsibly and that the people who are responsible for them maintain control over them. But within that, the goal is to build something that it would be very, very hard for an individual or an individual organization to control all of, and that would allow that kind of decentralized bottom-up sort of work. The question of whether and how you could then aggregate the data to share it is a question of standards. And that's where some of the role for a coordinating organization might come in. And it's one of the places where I think universities in particular could be especially good candidates for such a thing.
Hi, thank you for the presentation. I'm wondering about sort of the direction of our nation, like the federal government. I guess I would have said everyone knew we were headed into a knowledge economy, that we were in the thick of it and whatever comes next. And there was sort of a common understanding. And I'm confused personally right now. I don't know what reshoring manufacturing means, if anybody is even serious about that, and so on. So I'm just wondering, to what extent do you feel you know what the vision is of some of the, quote, I didn't mean that in a nasty way, but some of the people with the purse strings whose visions right now are associated with decisions and an allocation of funds. To what extent do you feel you know what that is? And how does it facilitate or hinder what, I don't know, what this work could be, should be? I hope that made some sense.
I think it does. So I spend a good bit of my time thinking about science policy. I think it's safe to say that I find the policy logic behind some of the decisions that are being made very confusing. It's contradictory. I think it's the question of whether one assumes good faith or not, I leave to each of you individually. It's hard to have an argument without assuming good faith on the part of at least some of the people that you are arguing with. My suspicion is that if we assume good faith, what we're seeing here is what I would consider to be a degree of overconfidence about certainty about what we'll need in the near to medium term. So I tend to read the progress of much technology as a kind of lurching and somewhat uncertain affair. The decisions that are being made about focus and budget cuts could be read as representing a fair degree of confidence that we're pretty sure what we need and we're pretty sure of the way to get it, so we're going to put our money there because we don't have much of it and this is the way to do less with more. I have opinions about whether that is the right way to do things, but that is the way that I can construct that in a, somebody made this decision from good faith premises trying to achieve the thing they're trying to achieve. That's the way that I would construct the story.